Eighth grade students, brand new year, 2024-2025. This is chapter 1, section 1, and this is the extra practice. So hopefully you took a moment to complete, I think there's 22 problems, and this is a video going over each of those. So problems 1 through 6, we're going to start off. And it says in exercises 1 through 6, solve the equation, justify each step, check your solution. So we are going to isolate the variable. We want to get this variable by itself. And the way we do that is we're going to use the inverse operation. So a question we ask oftentimes is what's happening to the variable? What's happening to the variable right here is 7 is being added to it. So we do the inverse of adding 7, which is, which is subtracting. I'm a little rusty, you see, which is subtracting 7. So we're going to subtract 7, and we have to balance the equation. Whatever we do to one side, we need to do to the other. So that leaves us with P, because a positive 7 and a negative 7 cancel. Negative 9 and negative 7 makes negative 16. So that would be my answer. It says to check your solution. That means we take the original equation and we're going to plug in this value, this solution for the variable P. So where we see P, we're going to put negative 16 plus 7 equals negative 9, and we're going to simplify this left side. We're not going to move things back and forth. We're just simplifying. Negative 16 and positive 7 leaves me with a negative 9, and we notice that the left side does equal the right side, so that means our solution is correct. That is checking your solution. How much time did that take? Not very much. Hence why it's good practice to check our work. So here we again, this time the variable's on the right side, but we still want to isolate it, so we have to look and see what is happening to this variable. 2 is being subtracted. The inverse of subtracting 2 is adding 2. So we're going to add 2 to both sides. Adding 2 to a negative 2 would cancel, leaving us with K on the right side. 0 plus 2 is 2, and that would be my solution. We can go back and check my answer. And we have 0 equals K minus 2. Let's substitute that proposed solution. And we're simplifying each side. We're not moving things. It's the most important thing to remember is here we were moving things. Here we're substituting and simplifying down that right column and that left column. Again, my variable is on the right side. 1 is being added. The inverse of adding 1 is subtracting 1. And we get W equals negative 11. We don't have to rewrite this as W equals negative 11. Negative 11 equals W is the same thing. We're going to check our work. We're going to simplify that right side, and we're good to go. Here, we're going to simplify first. If there are double operations, I'm going to simplify this. A positive and a negative make a negative. This is multiplication right here. So a negative times a positive times a negative gives me a negative. And the reason why I do it is it's easier to see the inverse operation. So the inverse operation of subtracting 3 is adding 3. G equals 7. I'm going to put it back in here, and I can plug in that value and do this. And 7 plus a negative 3 is going to give me a positive 4. I don't have to necessarily simplify that, but if I wanted to get rid of those double signs, I could have done that. Number 5, this is a fun one. So we have a negative 9. What gets rid of a negative 9 is a positive 9. And that is going to cancel. We're left with negative 5 equals Q. And we're going to check it. Make sure that that worked for my equation. Negative 9 plus negative 5 is negative 14. That worked. We have double signs. I'm going to simplify to make it easier for me to see what the inverse of adding 12 is subtracting 12. So S equals, that gives me a positive 3. I have S minus, well, I don't need that. Let's stop that. Hello. S minus 12 equals 15. So S is 3 minus a negative 12 equals 15. I'm going to simplify this because I don't know what 3 minus a negative 12. That's very confusing to me. So I'd much rather simplify that, and we would simplify the left side and we get 15 equals 15, and that's good. Now we're on to word problems. Shopping online, you find a skateboard that costs $124.99, which is $42.50 less than the price at the local store. Write and solve an equation to find the price at the local store. So, shopping online, you find a skateboard that costs $124.99, which is, that equals $42.50 less than the price at the local store. So we'll make that L for local store price minus $42.50 because it is that price is lower than that. This price is lower, $42.50 lower than the local price. So let's isolate the variable. We're going to add 42.50, add 42.50, and we get 9, we get 4, we're going to carry, that's 7, that's 6, 167. And so, since it's a word problem, I'm going to give a word answer. The local price, let's do it in English, the local price for the skateboard is $167.49. Notice my dollar sign went in front. When I do my cents, my dollars and cents, I have 2 digits. You can't have just 1 digit when we're talking about currency, and dollar signs go in front. Even though you say $167, you say the dollar after, but the dollar symbol goes into the front. You'd be amazed at how many people don't know that. Number 8 says, in exercises 8 through 13, solve the equation, justify each step, check your solutions. So now we want to look and see what is happening to the variable. This time something's multiplying it. So the inverse of multiplication is division or multiplying by the reciprocal. That's an important thing to know. Inverse of multiplication has 2 options. Option 1, division. Most people are very comfortable with that. But option 2 is multiply by reciprocal. Okay, so if 4 is being multiplied, we can divide it. We'll divide both sides. You get negative 8 equals y. That's one answer. Now, if we had negative 32 equals 4y, and we want to do the inverse operation of multiplication by multiplying by the reciprocal, what's the reciprocal of 4? 1/4. So we 1/4. Multiply by the reciprocal. We're multiplying by the reciprocal of 4, which gives you 1/4. And that still gives us negative 8. So it doesn't matter which one. And now let's check our solution. If we check, negative 32 equals 4 times negative 8. Remember, when we check, we're not moving things left and right. We are just simplifying the left and right sides, and that comes out correct. This is interesting. So r divided by negative 8, I'm going to rewrite this because to me, that looks more competent to me. In high school, you're not going to see signs like this very often. So I'm going to rewrite it, and we'd much more likely see this problem than this problem in high school. So r is being divided. The inverse of division is multiplication. We're going to multiply both sides by negative 8. Denominator cancels with the numerator. R equals negative 40. And then we're going to check our work. R divided by negative 8 equals 5. Negative 40 divided by negative 8 equals 5. Negative 40 divided by negative 8. 40 divided by 8 is 5. A negative divided by a negative is positive. And we get a correct answer. K divided by 3. So the inverse of dividing by 3 is multiplying by 3. Denominator cancels with numerator. It leaves us with K equals 12. Nice and genteel. Let's check it out. Yo, see if it works. We'll substitute 12 in for K. 12 divided by 3 is 4. And yes, the left side equals the right side. Z divided by negative 2. Inverse of dividing by negative 2 is multiplying by negative 2. Z equals negative 14. Check it out. Negative 14 divided by negative 2. Negative 14 divided by negative 2. 14 divided by 2 is 7. A negative divided by a negative is positive. And we get the correct answer. I'm again going to rewrite this using a division bar, or what we call a vinculum. What's happening to my variable? It's being divided by negative 1. The inverse of dividing by negative 1 is multiplying by negative 1. And we get b equals negative 9. Check it. 9 equals negative 9 divided by negative 1. Negative 9 divided by negative 1. 9 divided by 1 is 9. And a negative divided by a negative is a positive. That is correct. This is not my answer. Notice my answer is still over here. This is not we're just checking. When you check, you want the left side of the equation to equal the right side. P is being divided by 10. So the inverse of dividing by 10 is multiplying by 10. 10 in the denominator is going to cancel with 10 in the numerator. And 10 times negative 100. 10 times 100 is 1,000. A positive times a negative is a negative. In 8th grade, you should know those negatives and positives and products of signs. And now let's check and make sure that it works. Negative 1,000 divided by 10. We have 1,000 divided by 10. The zeros are going to cancel. That leaves me with 100. A negative divided by a positive is negative. So that is correct. Ooh, look at this. Now we got some fractions. So we again still ask what's happening to my variable. 4/7 is being subtracted from it. The inverse of subtracting 4/7 is adding 4/7. We're going to add 4/7 to both sides. A negative 4/7 plus 4/7 cancels, leaves me with my variable. We have like denominators. So when we have like denominators, we're going to add their numerators. So we get 6/7. That cannot be simplified or reduced. So we leave it like that. We're going to substitute it back in for k. Minus 4/7 equals 2/7. 6/7 minus 4/7. Like denominators, 6 minus 4 is 2. And yes, 2/7 equals 2/7. Negative 2/9 d, negative 2/9 d equals 18. What's happening to the variable? It's being multiplied. Now, it would be very difficult to do the inverse of multiplication by dividing. Who wants to do this hot mess? No, thank you. I don't want to do that. So this is an excellent example of when we should use option 2 for the inverse of multiplication. The inverse, the option 2, is multiply by the reciprocal. What's the reciprocal of negative 2/9? Negative 9/2. We flip it, and notice this would give me 1. Cancel, cancel, negative and negative make a positive, so that makes 1 and leaves me with my variable d. That's what our objective is. When we isolate, we want to get the variable by itself or have a coefficient of 1. Now, 18, I would not multiply 18 times negative 9, get a big number, and 1 times 2. I'm going to cross cancel. You better learn how to cross cancel when multiplying fractions. This 2 in the denominator can cancel with the 18 in the numerator. And that makes 1, that makes 9. 9 times negative 9 is negative 81 over 1, which gives me negative 81. Way easier. And then when we check, negative 2/9 times negative 81, does it equal 18? We're going to cross cancel. 9 goes into 81 9 times. 2 times 9 is 18. A negative times a negative is a positive. And we see that my solution worked. That means that this is correct. 6. Oh, are we intimidated by this? Did our hair just stand up because we see pi in a fraction? It's just like any other number. In fact, it's easier. So we still ask, what is happening to my variable? It's being added by pi over 2. So what's the inverse of adding pi over 2? Is subtracting pi over 2. That wasn't very hard. I know you thought it was going to be hard, but it's not. These are very simple logic and very easy. Now we have like denominators, so we're going to combine their numerators. 3 pi minus pi, if I have 3 pi's and I subtract a pi, how many you're left with? You're left with 2 pi over 2. Now you must simplify. You must, that's not a good looking star, must simplify all fractions. So we can simplify 2 over 2 to make 1, and we get h equals pi. That's what it is. We're done. Now we want to check. Let's check that. So let's take this and make this a little bit smaller. Move that over here. And let's check our solution. So if we check, h is pi minus pi over 2, does that equal 3 pi over 2? Let's check it out and see. Well, this is 1, so these are not like denominators, so I'm going to change 1 into an equivalent fraction with like denominators. And we see I made a mistake somewhere. Where did I make a mistake? I'm looking and I'm like, how did I make a mistake here? So let's see, 2 gives you 1 over pi. That's not working correctly. Did I? Oh, hello, it's a positive, not a negative. So positive, positive. Silly Mr. Mac. But notice I didn't make it work. So I found that it wasn't working. 2 minus 1 gave me 1 pi over 2, which didn't equal the right side. So I knew I was doing something wrong. So I went back. Oh, I didn't even copy down the problem. That's oftentimes where your mistakes are. So don't manipulate the problem to make it work. Go back, stop. It's telling you something. It's saying, hey, this isn't right. Don't just ignore it. Listen to it. So 2 pi over 2 plus, so same denominators. So 2 pi plus pi gives me 3 pi over 2. And yeah, that worked. So that's good. This is the answer, even though I made a little bit of a mistake there. 5t divided by negative 7.5. 5 is being multiplied. The inverse of multiplication is division, so we will divide. That leaves me with t equals negative 7.5 over 5. You cannot have a decimal and a fraction as your answer. You need to simplify this correctly. Simplify by either moving, doing a number of things. Don't throw it in the calculator. That's not how we simplify it. So I'm going to take this negative 7.5 over 5. I'm going to move this decimal to the right. So that decimal is here. I'm going to move this. So this is equivalent to negative 75 over 50. All I did was create an equivalent fraction without a decimal. Now I still have to simplify. Simplify, and this can be simplified because 5 goes into both of these numbers. So 5, or 25, make it even easier. I can reduce this by 25. That's negative 3 and 2. So 25 goes into negative 75 negative 3 times. 25 goes into 50 2 times. And that fraction is reduced. So negative 3 halves is the answer that I would come up with. Some of you came up with negative 1.5. I'll accept that, okay. Those are pretty much the only negative 1.5 I would accept also. So we're going to check. So 5 times negative 3 halves equals negative 7.5 over 5. So I can't cross cancel. I get negative 15 over 2 equals negative 7.5 over 5. So let's let's see right here. Did I do that? Yeah, that looks correct. T was that. That was okay. I think that's okay. Let's convert this. So if I double this and if I multiply this by 2 over 2, I get negative 15 over 10, but that's not the same. So Mr. Mac maybe made a mistake again. So don't, right? It's telling you, Mr. Mac, something is wrong. Where did you make your silly mistake? Divided by 5, divided by 5. That's okay. I move the decimal. I move the decimal, 75 over 50. This is okay. This is over 1, so we get negative 15 over 2. Oh, hello. Starting problem is equals, that's twice. I'm getting a little lazy here, but is negative 7.5. That's the original problem. It wasn't divided by. So does that equal negative 7.5? Let's convert this to negative 7 1/2. Let's convert negative 7 1/2 to a mixed number. 2 times 7 is 14 plus 1 is 15 over 2. Yeah, so this is the correct answer. We love making mistakes. At the beginning of the school year, I told you I was going to make mistakes. And it's just because it's realistic. Everybody's going to make mistakes, even the teacher. And what's good to see is how I go about it. How did I catch that I made a mistake? And what did I do after that? So I didn't just pretend and just write the wrong answer. I stopped, went back, checked my work, and found where I made a mistake. And I was able to find my mistakes because I show my work. Number 18. Ooh, this is, whoa, look at this. 4 plus 12 divided by 2. We're always going to do division before addition. So that's why I wrote it like this. I'm going to simplify this. This says 4 plus 6 equals negative 5v. 4 plus 6 I can do. 10 equals negative 5v. So notice that I simplified the left side before I started moving things. That's a really good, important thing. V is being multiplied by negative 5, so I'm going to divide by negative 5. I get negative 2 equals V. And now I'm going to check. So 4 plus 12. Notice I didn't do the addition before the division. Orders of operations tells me to do the division. So 12 divided by 2 is 6. Negative 5 times negative 2 is positive 10. 4 plus 6 is 10. And yes, that works, so I know that's my solution. This is an interesting one. You're rarely going to see this multiplication symbol like this. You won't see that in high school. So we have a plus 8. And again, we're going to do multiplication before subtraction. I'm going to simplify this right side. So that is 27 minus 10. We have a plus 8 equals 17. Once I simplify both sides, now I'm going to isolate my variable by using the inverse operation, and we get a equals positive 9. Let's check it. 9 plus 8 equals 9 times 3 minus 10. 9 plus 8, 17. 9 times 3 is 27 minus 10 is 17, which equals 17. Describe and correct the error in solving the equation. I love these problems. You have negative 2/3 p equals 4. Negative 2/3 is multiplying p. They are doing the inverse operation, which they thought was addition, and it is not. The inverse of multiplying by negative 2/3 is multiplying by negative 3/2. That's the correct. You need to do that to both sides instead of adding 2/3. So if we wanted to write it properly, negative 2/3 p equals 4. Let's multiply by negative 3/2. Multiply by negative 3/2. Any number multiplied by its reciprocal gives us 1. Leaves me with p. And then 2 in the denominator is going to cancel with a 4 in the numerator. Goes in 2 times. And I'm left with negative 6. So that is describe and correct the error in solving the equation. So we solved it. P equals negative 6. As c decreases, does the value of x increase, decrease, or stay the same for each equation? Assume c is positive. So as c decreases, does the value of x, so when we have x plus c equals 0, as c decreases, does the value of x increase or decrease or stay the same? So if, let's start with an example where c is big, what does x have to be? X is negative 10, okay? What if I decrease c? What if c is 5? What is my x value? X is now negative 5. What if c value, this is my c value, I'm just substituting values in for c, and it says assume that c is positive, so I'm putting in positive values. Let's do one more positive value. 0 is not positive, so I got to stay relatively. Let's do 1. So what does x have to be? X has to be negative 1. So what's happening to my x values? Are they increasing, decreasing, or staying the same? Well, my x values are increasing. So the value of x increases. Let's look at this next problem. Negative c times x equals negative c. So if we say, let's do negative c, so negative c is a positive number. Let's do 10. X equals negative 10. So what does x have to be? Well, x has to be 1. Let's increase my x value. So, as c decreases. So let's do 5. C is going from 10 to 5, even though that's negative. So x needs to be 1. Sorry, x needs to be 1. Well, that's a big. X equals 1 here. Stop writing negative, Mr. Mac. X equals 1. X equals 1. What if C, because remember here, oh, let's do this. Let's move this down a little bit. Let's bring this, because we didn't write the starting problem. I should have started with negative C, X equals negative C. So remember, we're substituting in for the C value, just the C, not the negative. So I'm just plugging in a 10, a 5, and a 1. Okay, I'm plugging in for those values. And so plugging in for that value just for C, and again, X equals 1. So it stays the same. And notice negative 10, negative 5, negative 1, that's increasing. That's moving towards the positive. X equals 1, 1, 1. It's going to stay the same. And let's look at our last example where we have X over C equals 1. So we're going to put in 10 for C. What does X have to be in order to make this an equivalent? So X needs to equal 10. Let's put 5 in there. What does X have to be? X has to be 5 in order to make it 1. And let's do 1. And X has to equal 1. So we see that we're plugging in for C. We plug in, and that's what we're getting. So what happened to my X values? They decreased. I like this problem. This is good. This is good conceptual. Hopefully you could do this and you can see how that works. That's not a simple one, but we're working on doing stuff that we probably haven't seen before. An example, a problem where we have to understand the fluency, the comprehension of how numbers work, numeracy, all these buzzwords this year. Number 22, 1/5 of the plants in a garden are grape tomato plants. 2/9 of the plants in the garden are cherry tomato plants. The garden has 18 grape tomato plants and 20 cherry tomato plants. How many other plants are in the garden? Explain. So 1/5 of the plants in a garden are grape. Okay, so 1/5 are going to be grapes, grape tomatoes. 2/9 are going to be cherry tomato. The garden has 18 grape tomato plants, 20 cherry tomato plants. That doesn't have anything to do with it because it wants to know. So this plus this plus this is going to consist of the whole. This is a part of the garden. This is another part of the garden. And this is the rest of the garden. So that's going to all add up to equal 1. So this is how I would do it. 1/5 plus 2/9 plus X must equal 1. So first thing I'm going to find common denominators, 40/5. We should know what the common denominator is. This should be common knowledge. And we should know that 9/45 is equivalent to 1/5. And we should know that 10/45 is equal to 2/9 plus X equals 1. So we get 19/45 plus X equals 1. We're going to subtract 19/45. We're going to subtract 19/45. These cancel. You're left with X equals 1 is equivalent to 45/45. And 19 from 45 is going to give us 26. 45ths. I think that's correct. Yeah, take 19. You got to borrow 2. 9 from 15 is 6. 26. Can we reduce 26? 13. No, you cannot. So how many other plants are... so this is 26 45ths consist of... That's the space. So that's the fraction of it. So what are we going to... How many other plants are in the garden? So how many plants? So if 1/5 is equal to 18 of those, and 20 represents that number of plants, then how many is this equivalent to? Well, 45ths. How many other plants are in the garden? How can I write that? 2/9 of the plants. Oh, of the plants. Okay. Oh, so 26 45ths of the plants. Is it 26? Wouldn't that be interesting? 1/5 of the plants in the garden are grape tomato. 2/9 of the plants. This is the number of plants. 20, yeah. Is it 26? Is it 26? Let's see. There are 90 plants in the garden. Oh, 52 other plants. Nope, that is not. So how do I do that? Let me think about this problem, right? That's of the plants, of the plants, of the plants equals the total number of plants. Where did I make my mistakes? So do we start doing 1/5 of 18 plus, that represents it. So those are the same. So I don't know if I'd multiply those. Well, this is a good problem. Let's try it. I'm going to just try it out and see if it works. It's too bad. That's 20. Now that's interesting. Cherry, 2/9. Okay. 20. Right? Do I do? No, I think 2/9 of the total. Oh, yeah. Sorry. I think I see it now. And sometimes you have to do it wrong in order to do it right. So 2/9 of the total, 2/9 of the total equals 20, right? Equals 20. So if I multiply that by 9 seconds, we get total equals 90, right? 2 goes in 10, 90. So the total is 90. So there are a total of 90 plants. And if there are 18 grape, 20 cherry, and then how many other for a total of 90? So that's going to give me 38 plus the other plants equals 90 minus 38 minus 38 other equals 8. That's 52. 52 other plants. Notice when I'm given a word problem, I'm going to do a word answer. And I think it was 52. Yeah, other plants in the garden. Yeah, right. So notice that equation to find the total, and then we know that there are, yeah. All right, there you go. Probably an hour video. Good practice, always good. Do the hard ones. It's okay to get challenged. Good luck.